Ladies and gentlemen, in this video, we're going to talk about how to find the slope of a line from a graph. So let's go ahead and rise the occasion over running away from it. Now, if you know, you know. Let's go ahead and find the slope.
When the rally's out of time and you say it will be fine, but I just can't find the line.
For finding the slope of a line from a graph, I'm going to show you two different methods. First being rise over run, which is primarily used in scenarios like this where a line is placed on a graph and you're trying to find the slope or the steepness of the line. And then I'm also going to throw in slope formula, which is useful for this scenario, but also maybe you're not given a graph and just given ordered pair. Slope formula comes in handy there as well. But I figured I'd just show you both. That way you kind of have it housed in one video, just in case you're learning rise over run and then need slope formula in the near future. So let's go ahead and take a look at the first one. And you need to first figure out, is my line positive or negative? And I think a lot of students at first struggle with, is this line actually a positive slope or is it a negative slope? And if you're not sure, you always start on the left side of the line, in this case, in the bottom left. And you need to trace your finger from left to right. Just follow along this line and see, well, is my finger going upwards or is it going downwards? And for this one, if you follow from left to right, you should easily be able to tell that this is going in the positive direction, whereas the negative from left to right would be going downwards like this. So now that we've determined that this is a positive slope, we're now going to use the rise over run method to start it off. So let's go ahead and choose 2 points that you easily know both coordinates to. You shouldn't be picking something like this, where you can't tell me what is that x coordinate. Is it 9? Is it 9.5? Especially if you have a broad range of numbers. Maybe this graph is skipping by 12s, and then you have a little box to figure out, well, is it 6? Is it 7? Is it 8? Is it 9? So this could be 9, this could be 9.5, but we're not entirely too sure. So to play it safe, you always want to pick 2 points where you see the lines of the coordinate plane meet, and that line runs right through them. So a good one would be right here. Another good one will be right here. I mean, you can mark a ton on this line. Sometimes there's only a few spots that you can actually mark, but I'm only going to pick 2 of them. So let's just pick these 2. And now we're going to use the rise over run method. All that means is you're simply going to count the number of units vertically for our rise, so either up or down. And then we're going to calculate our run, which is our horizontal change. So we're going to count how many units left or right it takes to go from one point to the other point. So let's go ahead and count our vertical change or our rise first. So we're going to rise 2 units because, again, we're skipping by 2s on this specific coordinate plane. So up 4 now, 6, 8, 10, 12, 14, 16, 18. And now we're on the same line as that other point. So we're going to stop with our vertical change. And now we're going to do our horizontal change or our run. So now we want to run to the right 2 units, 4, 6, 8, 10, 12, 14, 16, 18 for our horizontal change. So now for our formula, it is m equals, which is our slope. Rise was 18, which was our vertical change. And our run was a horizontal change. Well, what is 18 divided by 18? Well, your slope for this case is 1. So now let's go ahead and take a look at the slope formula to calculate this as well. So the slope formula is a little bit more in depth. You do have some math involved, whereas rise over run, you're essentially just counting boxes. So let's go ahead and pick 2 different points so we're not using the same exact ones. And if we do this properly, we should get the same answer as the counting method or rise over run method. So let's go ahead and pick maybe right here, and then I'll pick up here as well. And we need to write out what are our order pairs. So for this point down here, it's going to be 6, comma 6. And then the other one is going to be 16, comma 16. And for our slope formula, we need to label our x coordinates and our y coordinates. So for 6, comma 6, we're going to say that this is x1 and the other 6 is y1. I'm just labeling it 1 and 1 because this is the first order pair that I picked. And then the other one I'm going to label as my second x coordinate and my second y coordinate, x2, y2. And now, once you label these, it's simply plugging and chugging into the slope formula, which is m equals, or slope equals, y2 minus y1, which is essentially your vertical change, and x2 minus x1, or your horizontal change in the denominator. So let's go ahead and plug in our values. So this is going to be m equals y2 is 16, so we're replacing y2 as 16, minus y1, which is 6, all over x2, which was 16, minus x1, which was 6. So we end up getting m equals 16 minus 6 is 10 over 10. Well, 10 divided by 10, you still end up getting a slope of 1. So that's it for the first example. I have 3 other ones, and then we're moving on to the practice session where you try to find the slope of 4 different lines on your own. Now, for our next example, again, you want to start off with, is this a positive slope or is this a negative slope? Well, again, you start on the leftmost side of the line, and we're moving from left to right. And if you trace your finger along it, you're going in the downwards trend, meaning that your final answer should be negative at the very end because your steepness is going downwards or a negative decline. Okay, it's essentially like you going down a hill when you're snowboarding or something. Well, that's a negative slope. You're going downwards. So let's go ahead and find 2 points that we easily know the coordinates to. And you're going to notice for this line, you're very limited in the number of points that you easily know the coordinates to. There's a point here that works, a point here, and a point here. Other than that, there's no other points that you easily know the coordinates to because then you're guessing what is the x coordinate or what is the y coordinate. So again, we're only picking 2 though. I'm going to get rid of my origin for now. And let's calculate the rise over the run. And students ask this quite a bit. Does it matter which point we start with to calculate the rise over run? And essentially, no. I'll show you that you get the same answer regardless. Let's go ahead and start with the point on the bottom right of this line. So our rise, we're going from one point to the other. We are rising 2 units, 4, 6, 8, 10, 12, 14, 16, 18, 20 for our rise or our vertical change. And then you're going to notice for our run, we're moving left this time, whereas in the other example, we were moving right. Well, if you look at your x-axis, if you start moving to the left, your number's decreasing or getting into the negatives. So our run in this case would be we are moving -2, -4, -6, -8 for our run, which means for our formula, we would end up getting slope equals our rise was 20 over -8. And since that number is negative, our improper fraction is completely negative because a positive divided by a negative gives you a negative result. So 20 over 8 can be simplified. They're both divisible by 4. So 20 divided by 4, you would get 5 in your numerator and a 2 in your denominator. Now, if we started with the other point instead, we would do our rise, but you're going to notice that your rise is going downwards. So picture a thermometer. If it's going upwards, well, the temperature is getting hotter in the positives, and if it's getting cooler, well, it's going further and further into the negatives. So if we start with our other point and move downwards, that would be -2, -4, -6, -8. It would go down to -20. And then your running would be in the positives. You would be running +8. So the only difference is that the numbers are flip-flopped, which one's negative. But regardless, you get -5/2 for rise over run. So now let's go ahead and look at our slope formula. So I'm going to pick just 2 points. We'll pick this one. Again, we're limited, but I'll just throw in the origin this time around. So we need our ordered pairs. This first one is going to be -4, 10. And our origin, well, that's easy to work with. It's 0, 0. Now, again, I get another question is, does it matter which order pairs x1, y1, x2, y2? No. So let's go ahead and pick -4, 10 for x1, y1. And let's pick 0, 0 for x2, y2. Or you could flip-flop it and make -4, 10, x2, y2, and the other one x1, y1. You just don't want it where x1's with y2 or anything like that, because that's going to be a big problem. So now let's go ahead and use our slope formula by plugging in our values. So m equals y2 was 0, so plugging that in, minus y1 is 10 over x2, which is 0, minus x1, which is -4. We end up getting m equals 0 minus 10 is -10. 0 minus -4, so subtracting a negative turns to a positive, so 0 plus 4. So our denominator is 4. Well, -10 over 4, they're both divisible by 2. So you end up getting m equals -5/2 regardless as our final answer. So now let's go ahead and take a look at another example that's going to be a little bit different than a positive and a negative slope. Just like the previous 2 examples, I always have my students determine, is this a positive slope or a negative slope? But there are circumstances where it might not be the case. No positive or no negative slope. So this is one of those instances because you can't look at this line and tell me it's a positive slope or a negative slope. So let's go ahead and see what we actually get as an answer when we use the rise over run method. So we're going to pick 2 points. I'm just going to pick this one here and this one here. There's a ton on this line, unlike the previous example. And let's go ahead and calculate our rise. So we're going from one point to the other. And notice that our graph is skipping by 3. So we just need to be on the lookout for that. So up 3, up 6, up 9, up 12 is our vertical change. But what do you notice about the run? We're already at our other point. There's no horizontal change whatsoever. So when we plug this into our formula, we get m equals our rise was 12 over our run of 0. Well, if you punch this into the calculator and do 12 divided by 0, well, you don't get an answer back. You get an error. It's undefined. This line is too steep to even calculate, right? That's the way I word it to my students, that this line is completely up and down, which is why we say this line is undefined. So you don't want to put this as an answer. Don't do this, m equals 0. You're saying that the line doesn't even have a steepness at all, which is inaccurate. Instead, you actually need to put as an answer that m is equal to being undefined. You can abbreviate it if you want, undefined, okay? But this is one of those examples that kind of stands out. Hey, this line is completely vertical up and down. As soon as you see it, you should recognize right away, undefined. So now let's go ahead and showcase that we still get the same thing while using slope formula. So I'll just pick 2 different points. Let's say I pick this one down here and this one up here. So our order pairs are 12, comma 21. And then down here would be 12 comma -6. We'll say I'll flip-flop it just so you see that it doesn't matter. Let's say this is x1, y1, this is x2, y2. Plug it into our slope formula. We get m equals y2 is 21 minus y1, which is -6, over x2, which is 12, minus x1, which is 12. So we get m equals 21 minus -6. That turns to a plus. 21 plus 6, you get 27. 12 minus 12 is 0. And regardless, you get 0 on the bottom, making it that this slope is once again undefined for number 3. Now we have one more example that stands out just like this one does, and then we're into the practice session. Just like the previous example, it's very hard to determine is this a positive slope or a negative slope. So let's see what we get as a final answer when we do the rise over run method. So we're going to pick 2 points. Again, there's a ton of them on this line. So let's say I pick this one here and this one here. So let's calculate our rise, and right away you're going to notice that I'm not moving up or down from one point to the other. They're already on the same line. The only thing we can calculate is the run. So we are running once. Notice how it's going by ones now on the graph. 2, 3, 4, 5, 6, 7. So for rise over run, we get m equals, our rise was 0. We didn't go up or down or vertically at all. And our run was 7. Well, 0 divided by 7 doesn't give us undefined, but it does give us 0 as our final answer, which makes sense because this line doesn't have an incline to it at all. There's no steepness to it. It's just like you running on a regular sidewalk with no incline to it whatsoever. So when you have a completely horizontal line, your slope or your steepness is 0. Whereas if it's reversed, it's completely vertical, it's undefined. So now let's go ahead and showcase that you still get the same answer with slope formula, and then we're moving on to the practice session to see if you can figure out the slope of 4 lines on your own. So let's go ahead and pick 2 different points. I'll just pick this one here and this one over here. So this is -2 comma 3, and this one is 7 comma 3. We'll say this is x1, y1, x2, y2, and now let's plug it into our formula. So slope equals y2 is 3 minus y1, which is 3, so 3 minus 3 up top. X2 minus x1, that's going to be 7 minus -2. 3 minus 3 in our numerator is going to be 0. 7 minus -2, subtracting a negative, that turns to positives. So you get 0 over 9. Well, 0 divided by anything, you're going to get a slope of 0. Now let's make our way over to the practice session. Now it's time for the practice session. Do you have what it takes to go 4 for 4, calculating the slope of all 4 of these lines that you see? So I encourage you to pause the video, find the slope of all 4, and when you're ready to go, play the video and see how you did. So I'm assuming at this point you tried calculating the slope of all 4 of these and you're ready to go over the answers. I'm going to start off with the easy 2 just to knock them out of the way, and then we'll calculate the ones with the positive and the negative slopes. So for red, you should definitely have as a final answer your slope being 0. There is no steepness to this line at all. There's no vertical change. So red should be 0, not undefined, but 0. Whereas the blue one, this is the one that is undefined. It is completely going vertical or up and down. This is too steep to even calculate. It's undefined. So M should be undefined for the blue one. So hopefully you are 2 for 2 and didn't accidentally flip-flop those. Now let's go ahead and calculate the yellow and the purple one. So let's start with the yellow one. So I'm going to go ahead and pick 2 points. It looks like we have a point that we can utilize right here. And we're also going to pick this point down here. So let's calculate our rise and our run. So our rise, we're going downwards if I start with the left point. So down 2, down 4, so negative 4. And then we're running to the right in the positive, so 2, 4, 6, 8. So we get negative 4 over 8. So let's calculate that. M equals negative 4 eighths. 4 and 8 are both divisible by 4. So we get M equals 4 divided by 4. You get 1 up top. 8 divided by 4 is 2. And our slope is going to be negative 1/2 for the yellow one. Now let's go ahead and calculate it with slope formula. That way we know we get the same exact final answer. So I'm going to pick 2 different points. Let's say I pick this one down here, and let's do this one all the way up here. So that one is going to be negative 14/8. And this one down here is going to be 10, negative 4. We'll label this as x1, y1, x2, y2. We'll plug it into our formula. So we get m equals y2 was negative 4 minus y1, which was 8, over x2, which is 10, minus x1, which is negative 14. So m equals negative 4 minus 8 is negative 12 over 10 minus negative 14. That turns to addition, which is going to give us 24 in the denominator. Well, 12 and 24 are both divisible by 12, so we end up getting m equals negative 12 divided by 12 is 1. 24 divided by 12 is 2. And once again, we get negative 1/2 regardless. So for our yellow one, I'm just going to write it up top there and kind of fit it in that corner. We get m equals negative 1/2. And then finally, let's move on to the very last one, which is the purple one. So let me get rid of all the writing for the yellow. The purple one, let's pick 2 points. We are going to pick this one right here, and let's do one a little bit further up. Let's do right here. So the rise and the run, we are rising 2, 4, 6, 8, 10, 12 for our rise. Our run is 2, 4. So let's calculate that. We get m equals rise of 12 over run of 4. Well, 12 divided by 4 gives us 3 for our slope. And then let's make sure that we still get that with slope formula. I'm going to pick 2 different points this time. Let's say I go all the way down here, and then let's pick this one right here. So we are going to use our order pairs. So this is 4, negative 12, and this is 8, 0. Let's say this one's x1, y1, this one's x2, y2, and then let's plug it into our formula. We get m equals y2 is 0 minus y1, which is negative 12, over x2, which is 8, minus x1, which is 4. So we get m equals 0 minus negative 12 turns to plus 12. So we get a 12 up top. 8 minus 4 is 4. Well, 12 divided by 4, you get a slope of 3 for our final answer. So for the purple one, we get m is equal to a positive 3, which makes sense. It looks like it's going upwards from left to right, whereas the yellow one from left to right is going downwards. If this video helped you out with finding the slope of a line from a graph with rise over run and slope formula, please leave a like on the video, comment any other topics you want to see in the future, subscribe, turn on that bell for post notifications, and we'll see you in the next one with some more mathematics.
Sorry, baby, I just don't know the words or how to conjugate them. Was it really past tense?